Okay, so to start the second half of Chapter 7, we are still going to talk about exponents, but we are going to talk about rational exponents, or you might call them fractional exponents. We're going to talk about something new called radicals. And radicals are things I call roots sometimes. So if you've ever heard of the term square root, cube root, that's what radicals are. Radicals are a different way of representing an exponent. So example 1, we're really just going to talk about simplifying roots. So finding the root of something. So in A, this is read as the third root of 125 or the cube root of 125, which means a number times itself with 3 factors of that number is 125. Now, mental math is a little bit harder here, but it's understanding that x is really 5 because 5 times 5 times 5 is 125. And I will give you strategies for working through these eventually, but right now, be able to just understand what the third root means. It means a number times a number times a number, all the same number, is 125. For part B, this is the fourth root of 16, which means a number times itself this many times is 16. So if you take a minute and think about that, thinking of numbers that multiply that many times and be 16, that answer is 2. And if you think about it, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that's why the fourth root of 16 is 2. So as far as the guided practice goes, I want you to get some practice understanding what a radical means and then evaluating each of these radicals. I'm going to circle number 4 because maybe skip number 4 for right now. If you don't know what that symbol actually means, I'll explain it. But pause the video, work through these 4, and then when you're ready, I'll show you the answers to them. Okay, so for each of these, number 1, 3 times 3 times 3 is 27. So the cube root of 27 is 3. For number 2, it's 2 because 2 times itself with 5 factors of 2 is 32. Number 3 is 4 because 4 times 4 times 4 is 64. And then the last one, it's the square root of 36, which is technically the second root, but it's understanding when there's not a number there inside that little nook. That means the square root, which means 6 times 6 is 36. You are going to become much more familiar with square roots than any other type of root later on. So understanding that that means the second root of 36, which means a number times itself is 36. That number is 6. Moving ahead, converting between radicals and rational exponents really is just understanding that the root, if I'm going to rewrite a root as a fractional exponent, that means that the number inside this little nook here in this root, I call that the root, okay? If I'm raising this to a power, call that the power or the exponent. So whenever we write these as fractions, it's always a to the power over the root. And I'll show what I mean by that in a second, converting between the two. In part A, rewriting 12a to the 2/3 in radical form, that really is 12 times a to the 2/3. So this would be 12 times, and the way I'd write this is, I'd write that root symbol, and I want you to understand what this means. It's the third root, the cube root of a squared. The power is 2, the root is 3. So the power is on the top, the root is on the bottom. You could put this a squared in parentheses if you want, that's fine. But really just understanding power and root. The power is what the variable is being raised to. The root is inside that root symbol, that radical symbol. In part B, it's realizing that this entire quantity is being raised to the 4/5 power. So I'm just going to draw one big radical symbol, okay? and it's going to have 64a in parentheses on the inside. Now that is being raised to the fourth power, which means the root is 5. So understanding the difference between a power and a root, all right? So in the guided practice, again, just work through them best you can, and then when you're ready to go through the answers, I'll explain them. But it's just getting comfortable working between roots or radicals, radical form, and exponential form, or rational exponential form. So rewrite these, pause the video, and work through them. When you're ready, I'll explain the answers. Okay, so for each of these, it's understanding that in A, this is probably the easiest one I could show you, a to the 5/6. 5 is the power, 6 is the root. So 6 goes in the radical, 5 is written as the power. For part B, 5 is not being raised to the 1/3 power. So it's 5 times, that's what that dot means, times the cube root of x. If you wrote x to the 1, that's not wrong, but we don't need to write x to the 1. We can just leave it as x. In part C, it's understanding that this entire quantity is being raised to the 2/3 power because of that parentheses. So that parentheses tells us the entire quantity is being raised to the 2/3 power. The cube root is 3, third root, and then it's being raised to the second power. 2 is the power there. So we converted exponential form to radical form. Now we're going to convert radical form to exponential form. So in example 3, part A, 3 is the power, 5 is the root. So when I raise this, the power is on the top, 3, the root is on the bottom, 5, and that's it. Okay, so in part B, it's recognizing that this entire quantity, 27d to the 5th, is under the cube root, okay? So when I rewrite this, I'm going to rewrite it as parentheses 27d to the 5th, all raised to the 1/3 power. So now it's remembering our properties of exponents. We are raising each of these factors in here to the 1/3 power. If you do 27 to the 1/3 power in your calculator, that becomes 3. D to the 5th to the 1/3 is our property, power to a power. That's going to be D to the 5 times 1/3 power, which I would just write as 5/3 power, and that would be it. So those properties we learned before, they're not going away. All right, those properties are not going away. We are applying them in different contexts. So I've got another guided practice for you to try to help you build some confidence in simplifying these. So take a minute to work through these 4 problems, and then when you are ready, I'll show the answers, and then we'll do a quick application problem, and then you're going to move on to some practice. Okay, so for these guided practice problems, I thought A and B should have been the simpler ones, so hopefully you at least tried A and B and got those. C and D are a little bit trickier because it's understanding that the quantity 4y is all being raised to the 5th power. So that means I raised both 4 and y to the 5th power. That's why I got 1024y to the 5th. That's all under the square root, which we talked about before. You convert a square root to the 1/2 power. If I raise both of those to the 1/2 power, I get 32y to the 5/2 power. In part D, it's kind of similar. This quantity, 256a to the 8th. Now, 256 is not being raised to the 8th power because it's not all inside of a parentheses like example C here. So this quantity is under the 4th root, which means it's being raised to the 1/4 power. So what I did was I raised each factor, each part, to the 1/4 power. So that's why I got 4a squared. So the last example really is just us using a radical expression to evaluate a realistic problem. It says you can estimate the metabolic rate of living organisms based on body mass using Kleiber's law. The formula, R equals 73.3 times the 4th root of m to the 3rd power, relates metabolic rate, R, measured in calories per day, to body mass, m, measured in kilograms. What is the metabolic rate of a dog with a body mass of 18 kilograms? So essentially, in problems like this, we're given a formula. You're looking for one of the variables. You're given the other variable. In this problem, we are given m. We are given the mass of a dog. So we just have to substitute m out, substitute in 18, and evaluate for r. So r equals 73.3 times the fourth root of m to the third. Now, we know m is 18, so I would do 18 to the third. Sorry, that's 2. 18 to the third. Now, to make this easier to punch into your calculator, I'm going to do 73.3 times, and I'm going to write this as 18 to a rational power. I'm going to convert it to exponential form, to the 3/4 power. 3 is the power, 4 is the root. So if I do 18 to the 3/4 power, and then I multiply that by 73.3, that means r is 640 point, and let's just round in one decimal place, 640.6 calories per day. So essentially what this is talking about is how many calories you burn in a day. If you're a smaller animal, you don't need as much food, so you don't burn as many calories in a day. If you're a bigger animal, you need more calories to survive. You burn more calories in a day. So in the guided practice, I'm just going to kind of work through this one to save you a little bit of time. Guided practice number 4, we're doing the same expression, but we're given an animal, man, with a different mass, 75 kilograms. So the mass is now 75. So I'm essentially going to take the expression we wrote in the last example, 73.3, and we already know it's going to be 75 to the 3/4 power since we already converted it. So 75 to the 3/5 power times 73.3. So the rate there is 977.6. I would say 0.6 calories per day. Okay? So what I'm assuming here is that this assumes calories per day if you just sat on your butt and did nothing. Okay? How many calories you'd burn just by being alive. Because you burn calories by just being alive. Breathing, your heart pumping, that burns calories. Now, if you're active, you need more calories. But this is just the bare minimum you need to survive. I would think that's what this means. Okay? So it's really just understanding how these expressions work and then how to evaluate them. So you should be ready for a little bit of practice now. Please, please, please pause the video sometimes, go back, check to make sure that you have these notes taken and that you're able to use them, all right? Because we put a lot of time into these because this is the substitute for our book. This is our main resource for remembering things, okay? So you got the next step in the lesson to go. Email me with any questions, and we'll go over any questions you have additionally on Friday.